Okay, this question says, forces acting on an object combine to give a net force that is non-zero. What can you say about that object? Now first, before going into the answers, remember that whenever we say that the net force is non-zero, we are saying there is a net force. That's what we are saying. That's the bottom line. If there is a net force, then that's the domain of Newton's second law of motion. What does Newton's second law of motion say? Whenever there is a net force, there is an acceleration. The acceleration and the net force are directly related and are in the same direction. Again, whenever there is a net force, there is an acceleration. The net force and the acceleration are directly related and are in the same direction. Newton's second law also says that the acceleration is inversely related to mass. The more mass, the more difficult to accelerate the object when subject to the same net force. Again, for the same net force, objects with more mass are more difficult to accelerate. That's also part of Newton's second law of motion. So again, first part, whenever there is a net force, there is an acceleration that is directly related to the net force and in the same direction as the net force. Remember, directly related means they behave the same way. When the net force increases, the acceleration increases. When the net force decreases, the acceleration decreases. Inversely related means they behave the opposite way. When the mass increases, the acceleration decreases. When the mass decreases, the acceleration increases. Okay, let's answer the question now. So here they say we have a net force since it's non-zero. What can we say about the object? Let's look at the answers. If it is at rest, it will remain at rest. That's not saying anything about the object accelerating because of the net force. So this is not correct. If it is moving, it will keep moving in the same speed and the same direction. Again, that's not talking of an acceleration. For an object to accelerate, you need to have either the speed change, speed up or slow down, or the direction change. Neither of them happening here. Here, it will accelerate in the direction of the net force. That's a partial statement of Newton's second law of motion. So that's the correct answer for this one.